For this video, we'll be doing lesson 4-9, where we look at scientific notation. Scientific notation is, wrong color, a way to write numbers using powers of 10, a number written in scientific notation is written as a product of two factors. So basically what it does is it takes really big or really small numbers, so numbers that have a lot of zeros, either way, the zeros are either after or before, and it turns them into something where you have like decimal number times 10 to the power of something. So like the example they have right here, right? There's a lot of zeros after the 7 and the 5. And then you can turn it into 7.5 times 10 to the power, which we're going to figure out how you count the power. Okay? So before we do that, we're going to, off to the side, down here, we're going to figure out when it's a positive or a negative exponent. So let's say, for example, 7, 5, 0, 0, 0, 0, 0, 0, 0, 0, 0 is going to have a positive exponent. And we know that because if in standard notation it's a big number, meaning the zeros are on the right. Okay, that's how we're going to know it's a positive exponent. If we have something like 0.000000000000075, then it would be a negative exponent. So we know that because if in standard notation it's a small number. So the zeros are on the left. Okay, these are your two little clues to help you remember. So if you have a really big number like this, where the zeros are on the right, the zeros are on the right, it's going to have a positive exponent when we do 10 to the power of something. If it has zeros on the left and it's like 0 point and then a bunch of zeros, you're going to have a negative exponent when we do, it's like 7.5 times 10 to the negative something. All right, so let's figure out how we know what our exponents are going to be and where to put our decimal. So, also this is standard notation, right, when it has a lot of zeros, and then this is scientific notation when it does not. So first, the factor at the beginning has to be greater than or equal to 1, but less than 10. So the number that you put there has to be greater than or equal to 1. So you can have 1, 1.1, 1.2, and so on, but it has to be less than 10. So you can have like up to 9.9, but you can't have 10. Then the second factor is 10 to the power of something. So to figure out what the power is going to be, do you see how the decimal is between the 7 and the 5 on this one? Right here? Well, on this big number, since there's not a decimal written, that means it's implied that it's at the end. So to figure out the power, we're going to have to count how many times we have to move that. So if I look and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then it ends up between the 7 and the 5, which is where I want it over here. So since I had to move it 12 times, my exponent is going to be 12. So again, I figured that out because the first factor has to be greater than 1 but less than 10, and 7 and 5 are my two numbers, so 7.5 fits. And to move it, I had to go 12 places, so I put 10 to the power of 12. So it's always going to be powers of 10, like 10 to the something. It will always be a 10. So you can change numbers from scientific notation to standard notation simply by following the product. So if I put in my calculator 7.5 times 10 to the 12th, I should get this number if I did it correctly. Okay, so let's look at some examples down here. So about, ooh, that's a big number. It's talking about how many people visited the Eiffel Tower in the year 2000, and we're going to write this number in scientific notation. So since it doesn't have a decimal, it's implied that it's at the end, right? And you're going to have to move it until you get to a point where the first factor is going to be greater than 1 but less than 10. So I'm going to move it between the 6 and the 3 so that I get 6.3. So I'm going to move it 1, 2, 3, 4, 5, 6 places so that I get 6.3. And then my answer would be 6.3 times 10 to the 6th because I moved the decimal point 6 places, which means 6 is the exponent of 10. So I have 6.3 because those are my numbers at the front. I went until it was 6.3 because that falls between 1 and 10. And then I counted how many times I had to move my decimal to get 10 to the power of 6. It works the same way when you're going the other direction, but like we said over here, when it has zeros in front of it, 0 point something, you're going to end up with a negative exponent when you write your answer. So we have 0.00037. We need to move it so that our factor is greater than 1, but less than 10. So we're going to move it until it's 3.7. So that means we're going to go 1, 2, 3, 4. We're going to move it 4 places. Okay, we moved it 4 places, so we're going to use an exponent of negative 4 because we started off with this number that had zeros in front of it, which means we have a negative exponent. So 3.7 times 10 to the negative 4. So you do it the same way as you would with the positives, but since it was a tiny number with all the zeros in front of it, it's a negative for your exponent. All right, so go ahead and flip your paper over when you're ready. You can also go the other way, right? So you can take something from scientific notation and write it in standard notation. So I find the easiest way to do this, I'm going to do it off to the side. I'm going to start with 3 and 6. I'm not going to actually put the decimal because I'm going to end up moving it. And I'm going to move it 4 places, right? So I'm going to go 1, 2, 3, 4. So I draw the little loopies underneath, and then I go back and I add zeros to see how many zeros I'm going to need in my answer. So my answer is going to end up being 36,000 because I have moved it 4 places, 1, 2, 3, 4, and then put the zeros, which means I need to have 3 zeros at the end of it. You can do the same thing here. 7 and 2, we're going to move it 3 places, but now we're making it so that the zeros are in front of it. So we're going to start here and we're going to go 1, 2, 3. Then we go back and add our zeros and our decimal point. It looks better if you put a 0 in front of that too after you've added your decimal. So 0, 0, 7, 2. But again, you just start where it was in your first factor and you move it however many places it says as your exponent. Since it was a positive 4, we put the zeros after. Since it was a -3, we put the zeros before. We went 1, 2, 3 places, put our decimal, and then when we have small numbers, it just is better form to put a 0 in front of your decimal. Don't get confused, do that last. Make sure you put the zeros inside your loopies first and your decimal so that you end up with the right number of them. So that's how you go from scientific to standard form. Okay, the last piece you're going to be doing is taking two things that are in scientific notation and multiplying them together. It looks like it's going to be a lot of steps and a little bit confusing, but once you see the pattern, it's not so bad. So 1 mole of any element contains 6.02 times 10 to the 23rd atoms. If each hydrogen atom has a mass of approximately 1.67 times 10 to the -27 kilograms, what's the approximate mass of 1 mole of hydrogen atoms? So we're basically going to take those two big numbers in scientific notation and multiply them. Step 1, we're going to use our commutative property where we put all the things that are the same together, right? So we're going to take 6.02 and we're going to put it there. We're going to take 1.67 and we're going to put it here. We're going to take 10 to the 23rd and put it here. And then we're going to take, oh, we already used yellow. We're going to take 10 to the -27 and put it here. So again, all I did was sort out my two number factors and my two exponent factors and put them in order. Now, I can do the math for those two number factors. 6.02 times 1.67 is going to give me 10.01. All I did was multiply those. Then I still have 10 to the 23rd and 10 to the -27. When we have things that have the same base and they're being multiplied, we add the exponents, right? We did this recently. So we have 10 to the 23rd, essentially, plus -27. So we're going to end up with 10 to the -4. Why is this not our final answer? Why is that not the end of this? I have a factor and I have times 10 to the something. Well, the answer is because this 10.01 is not less than 10, right? The first factor in scientific notation has to be greater than 1, but less than 10. So what they did is they turned 10.01 into 1.01 times 10 to a power. So we have to do 10.1. If we moved it one place over to end up with 1.01, it's 10 to the 1. Okay, and we still have times 10 to the -4 because that was this piece. So all they did here was take 10.1 and turn it into 1.01 times 10 to the 1 because this is greater than 1 but less than 10. Then we add our exponents one more time. And we end up with 1.01 times 10 to the -3. So our answer is just 1.01 times 10 to the -3. So you just have to pay attention when you get to what you think is the answer and make sure that the factor in the front is not greater than 10 or less than 1, because if it is, you'll have to move and turn it into its own scientific notation and then do that adding step one more time. All right, so let's look. Write each number in scientific notation. So let's do A together. So remember, our decimal is implied when it's not written, as it is implied that it's at the very end. We're going to move it 1, 2, 3, 4, 5, 6, 7 places because we have to get far enough over that our first factor is going to be greater than 1 but less than 10. So we end up with 5.45 after we move it times 10 to the 7th. Remembering that it's a positive exponent when the number has the zeros on the right and it's a big number. Okay? And that this factor has to be greater than 1 but less than 10. So go ahead and pause your video and do B on your own, paying attention to the fact that the zeros are on the other side this time. All right, so what you should have done for this one, right? We're gonna move it 1, 2, 3, 4 places so that it ends up between the 2.1. So we should have 2.1 times 10 to the negative 4 because the zeros were in front of the number on that left-hand side. It was a small number. Okay, to show our work for these ones, right, we're gonna have 3, 2, 1. I don't actually write the decimal, but I'm gonna start there. 1, 2, 3, 4, 5, 6, 7. Then I go back and I add my zeros after I've drawn my loopies to help me keep count. And then I'm gonna write my number answer all together. So I have, how many zeros? 1, 2. Okay. I can add some commas. Okay, so that would be my final answer. Since it was a positive exponent, I made sure my zeros ended up on the right and that it was a big number. So go ahead and pause the video. This is how you're showing your work on your homework, so make sure you have that written somewhere and then your answer. Pay attention to the -8. Pause your video and give that one a try. Okay, so I have 5, 9, starts here. 1, 2, 3, 4, 5, 6, 7, 8. Go back and add my zeros. And then my decimal point. So I should have 0 point, and then how many? 1, 2, 3, 4, 5, 6, 7, 5, 9. Okay, should be my answer. All right. So this is another one of those multiplying ones, right? So step 1, we're gonna sort and reorganize. So we have 7.1 and 8 that are numbers, and we have 10 to the -8 and 10 to the 4th that are powers, right? So we're gonna do 7.1 times 8 times 10 to the -8 times 10 to the 4th when we rewrite it. Because we sorted the numbers to be next to each other and the powers to be next to each other. Then we have 7.1 times 8, which is going to give us 56.8. We still have times 10 to the -8 and times 10 to the 4. Since those have the same base, we can add those exponents, right? So we're going to have 56.8 times 10 to the -8 plus 4. Okay, moving over here. 56.8 times 10 to the -4 is what we would get from that. Is that our final answer? No, because 56.8 is much bigger than 10, right? It has to be between 1 and 10. So if I were to move my decimal place 1 over on that, I would end up with 5.68 times 10 to the 1. So again, all I did was turn 56.8 into 5.68 times 10 to the 1. And then I still have times 10 to the -4. And then I just add those again. So I have 5.68 times 10 to the 1 plus -4, which is really just 5.68 times 10 to the -3 as my final answer. So sorting, do the first set of multiplying, add the exponents for those, get to this answer and realize that 56.8 doesn't work. Turn 56.8 into 5.68 times 10 to the 1. We still have that times 10 to the -4. We combine those, so you have 5.68 times 10 to the 1 plus -4. And then you get 5.68 times 10 to the -3. All right, so you're gonna pause the video and do number 4 on your own. This is your first thing you're using, and this is your second thing you're using. But you're doing exactly what we just did. Okay, so pause your video and do number 4 on your own. Okay, so when I sort those out, I would have 1.67 times 6 times 10 to the negative 27 times 10 to the 3. 1.67 times 6 is going to give me 10.02 times 10 to the negative 27 times 10 to the 3. I have both those powers of 10, so I'm going to have 10.02 times 10 to the negative 27 plus 3. 10.02 times 10 to the negative 24. Am I done? No, right? 10.02 is bigger than 10. So I have to turn 10.02 into 1.002 times 10 to the 1. All right, all I did was move the decimal one place and have a 10 to the 1 times 10 to the negative 24. Then I'm going to add those powers again. 1.002 times 10 to the 1 plus negative 24 is 1.002 times 10 to the negative 23. And that is my final answer. This wraps up lesson 4-9 on scientific notation.